Hello, welcome back. So this video is very special video because this is a video on Markov decision process, Markov decision tree. So we have basically set up the environment for our UGV for movement. Next, what we basically did, we try to figure out how UGV will travel its path using the method Bellman equation. But do you think the Bellman equation is enough for the UGV to travel in the path? The answer is no. So what we are going to do, we are going to try to make the things slightly more efficient for a UGV to travel into any environment. So let's try to figure out. So this was a path which was decided by the Bellman equation from one place to other place how UGV will go. Okay, and your UGVs was ready and it was traveling to this different path like this. So it can travel this way. It might travel from this way. Okay, it might travel from this way. Okay, okay, and if it is here, it's simple way. But the thing is, the things are not so simple as it look like here. Okay, so this is basically something different in the reality. What is there inside the truth? So let's try to understand. So this is basically called as the deterministic search. Here we have not kept any intelligence. We have just given the algorithm that you should go here. But in actual environment, when UGV try to figure out the path, there is no 100% chance that or probability that the UGV will travel to this path only. UGV may take some other path also. So what is the meaning of that? So in the non-deterministic search, basically not the 100% that your UGV will go over here. Your UGV may go over here. There's a 80% probability of that. Then there's a 10% probability that it may go on this side, or 10% probability it may go on this side. So basically there are two possibilities that your UGV may go on this side or you may go on this side or it may go on this side. Okay. So what we are actually going to do, we are going to understand the UGV in the non-deterministic way. Okay. So your equation, what we have created for a Bellman equation, now going to modify. So here we have taken only one value, that is 1. Uh, and this one value was basically the block value. Whatever block value was there, we have taken that value, multiplied by the gamma, and we got the new value over here. Okay. But now the things will going to change, and how the things will going to change, we'll try to figure out that. Okay, let's see. So now this is will be divided into three parts. The first 80% part, then the 10% part, then the 10% part. Okay, 80%, 10%, and the 10% part. Okay. So the equation will be going to change as summation of probability, that is 0 0.8, 0 0.1, and 0 0.1 multiplied by different value of V. You can see over here. So this is V1, this is your V2, and this is your V3. So you can directly write down as V of dash summation of the value where your state, this S is basically called as the state and A is basically called as action, will going to change as per your requirement. Okay. So this was the old value which we have calculated. I want you to remember some of the values from this because these values we are going to take as a multiplication to create the new values. Okay, there are only new values are 1, 0 0.9, 0 0.73, 0 0.81. These old values we are going to use for calculation of a new values. Wow, let's start. So let's take this block first this block. Okay, so I want you to take the screen capture of this so that you can use this value for the further calculation. Okay, so this value is 1 now, right now. What is this value? This value is 0 0.9. Okay, and it is banging on the wall, so wall have the 0 reward. Okay, so we have to multiply 1 with 0 0.8 and 0 0.9 multiplied by 0 0.1. So the calculation go this way. 0.8 multiplied by 1 is basically this calculation. Okay. And then we have 0.1 multiplied by 0.9. That will be this calculation. 0.1 multiplied by 0.9. Okay. And then we have 0 multiplied by 0.9, 0.1, the wall calculation. The gamma we have kept at 0.9 itself. So we got basically 0.8 multiplication of this. So this multiply with this multiply. Okay. So we get the answer like this. 0.8 multiplied by 1 plus 0.9 multiplied by 1, addition of these two multiplied by gamma, we get this value. Okay. So now this 0.8 is ready for us. Let's consider for this. So now here we have a 0.8, here we have a 0, here we have a 0. Okay. So 0.8 multiplied by 0.8, 80% 0.8 multiplied by 0.9, because 0.9 we have decided as gamma. So this is coming as to be 0.58. Okay. So 0.58. Now this block. Okay. Now this calculation 0.58 multiplied by 0.8. This value was, you just remember this value. Okay, this value was 0.73. So this is 0.73. Okay, so this is 0.73 multiplied by 0.1, and we get the answer. Okay, 0.48. So the 0.48 will be filled. Similarly for this calculation also. Okay, 0.408 multiplied by 0.8 and so on. 0.35. This calculation is also simple. 0.32. Okay, I want you to see this calculation. 0.73. This 0.73 was here. Okay, old calculation. Okay, so now this value. Okay, now this one will be the very interesting part. You can see we have decided that our UGV should go to the obstacle. Actually, if the UGV is here, if the UGV is over here, uh, then we want our UGV to go on this side. But the thing is, we are intentionally keeping that UGV should bang on this side. It may bang 80% time on this side. It might go 10% on this side, 10% on this side. But we don't want our UGV to go to the danger. That's why we are banging the UGV on this side. So this is a very special addition which we have done. I want you to note this. You see, in the previous stage we have using the Bellman equation, the arrow was upper side. But now we are keeping the arrow on the obstacle side. So it may bang on the obstacle many times, but it might travel to the upper side or it might travel to the lower side. There is only 10% chance, but we are not going to lose our UGV to the danger. Okay, so the banking is allowed, but the losing of the UGV is not allowed. We want our UGV to be reliably reached to the location, not to the danger. Okay, great. So now the new calculation will going to come over there, and that calculation is 0.48. Okay. So now here also you can see we don't want our UGV to go from here, because if the UGV come over on this block, it may go on this side. So we want our UGV to go take this path itself, even if it is a longer path, but we don't want our UGV to go from this path. This is not allowed. This path is not allowed because there's a danger on this side. So again, the calculation of this will going to change. Okay, 0.73, 0.23. Again, if the UGV is over here, I don't want my UGV to go on this side. Okay. So maximum chance that it should go on this side. Only 10% chance that it might bang on upside. We cannot take on the reverse path. So we have to take this path. So this will be the new calculation will going to come, and that will be 0.81. And the last one is also very interesting, that I want my UGV to bang over here, not go over here. So, okay, so instead of this arrow, I have decided 80% on this side. 80% it bang on this side, 10% chance that it may go on this side. But it's perfectly fine. We may save our UGV going to the danger. Okay, so the new calculation of this will also going to come. It is 0.02. So now the things are very simple. If the UGV is standing on particular location, let's see if the UGV is standing over here. So there are two ways. It may go from this, or it may take this path. Now, what UGV will take? UGV will not take this path, because if it is here, it will check what is the maximum reward. It is reward is this side. Now it will come. It will check here reward is 0.14, but here reward is 0.21. So this is a perfect path. Okay, the rest is you can able to see and understand. If the UGV is standing over here, it may take this but directly. Okay, if the UGV is on this side, it is not going to go on this side. It is going to go from this side itself, because the maximum reward is on this side. Great. So old calculation and the direction we will try to see. Okay, this is the old calculation and this was the direction. So this direction I want you to mark down. 1, 2, 3 and 4. I want you to take a screen capture or just glance it for a while, and then we can go for a new one. Okay. And as per the new calculation, what is the direction? Okay, the direction this way. 1. Okay, it was before that it was this way. Okay, in the previous it was this way, now the things are changed. In the previous it was upside, now the things are changed. In the previous it was on this side, now the things are changed. Okay, old versus new, very clear to us, very clear. Directions are completely changed. So we may bang into this side, but we are not going to danger, that is for sure. We may bang on this side, but we are not going to danger, that is for sure. Great. So now let's see case number 1, how the UGV will going to travel. Okay, this is very fun to watch. If the UGV start point is here, it is going to go from here, 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 and the final target place is reach. Okay, if case number 2, if the UGV start point is here, it is going to go from this side, or it might take the upper path also. Okay, it's completely based on the values. If the case number 3, if the UGV is standing over here, it may take the upper path also. I already told you it may take two path, but it is not going to go into the danger for sure. Okay, so mark out decision process. This is a very interesting part, and it help us to actually decide the exact path for this. I hope this part is clear. So new equation, we have to write it down somewhere. This will be helpful for creating the Q learning. I hope this part is very much clear to you. Stay tuned. Thank you very much.